Hello, welcome once again to sagemath tutorial. In today's class we are going to discuss algebraic expressions used in sagemath. Sagemath uses the standard symbols addition, subtraction symbol, for multiplication a star symbol, and division forward slash for division, and exponentiation for power, generation of power expressions, this symbol, and for factorials, this exclamation symbol. These are the commonly used symbols. Unlike other programs, multiplication can only be performed by the star symbol. You cannot use cross symbol for representing or for multiplying two expressions or numbers. You must strictly use the star symbol. To generate numerical output in decimal form, if you want to generate a numerical output in decimal form, otherwise it will give you output in the integer form. If we want it in decimal form, we use the command n. See, n in bracket expression comma digit equals the number of digits actually required. Here it is digit equal to 3 used. That means in the answer, in the numerical answer, you will get in the decimal place 3 decimal places. We can see we get 3 decimal places. So but if you want more decimal places, you can use that much number there, and if you want less, then that number can be given there. Sage can perform calculations to arbitrary precisions. It can perform calculations to arbitrary precisions and handle numbers that are arbitrarily large or small. So Sage has this freedom. It can handle numbers of any size. In Sage, the number, it can handle some letters or some words to represent numbers. To represent pi, we use pi. Pi has some value. It's an irrational number, and its decimal place never end and never recur, never repeat and never end. And but we approximately use some the number 3.142. Here only 3 decimal places are used. With some specified number of decimal places we approximate the number pi or any number like or rational numbers like pi are approximated, and it's more convenient to use that kind of approximation in sagemath. So if you for generating that kind of approximation, the general syntax is given here for representing decimal numbers in sagemath. So that kind of expression can be used here to approximate the value of pi. That is n in bracket. In bracket, first you write pi, then comma, digits equal to 4. Then it will give you 3 decimal places. The answer, the digits equal to, since we write digits equal to 4, it will give number correct to or the approximate value of the number pi correct to 3 decimal places. Another example, if you write n of pi and then n in bracket pi comma digit equal to 20, now you can count the decimal places, number of decimal places. You can see the output will be like 3.14, 15, 92, etc. The last two places are filled by 8 and 5, and you can count number of decimal places in this output 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. 19 prices are there. Okay, then come to this expression n cap, sorry, 6 cap, then in bracket 5 cap 2. So this stands for 6 raised to 6 raised to 5 raised to 2. 6 to the power 2 to 5 to the power 2, and that's the number. But it's a very, very big number, and it is actually it contains this much decimal places. It's an integer. That's clear. It's an integer, and see, it's an example of how sagemath handles very big numbers. Now, it can handle even very bigger than this number, this kind of number, very, very big number. But if you use very big numbers in calculations, and if the calculation steps are very lengthy, then you may not get very easily its output. The procedure of creating output will take a very long time. So that's the disadvantage of this kind of using very big numbers. So we will limit in most of our calculations. We will limit our attention with very small numbers, or numbers that can be handled easily. Now see the factorial, another one, factorial. This is also a standard word function, factorial function, and if 5 is used in factorial of 5, it can generate factorial of 5. That the value is 120. So if you want to generate a factorial of any number, you can write it in this form: factorial of n, factorial n. Here n is a natural number. Now we can discuss the rules regarding the assignment operator and the equal operator. See, in normal writing in mathematics, when we use when we write mathematics, we use the symbol equal symbol. We use very frequently. I think it's a symbol very frequently, or most frequently used symbol by mathematicians, equal, because in every expression, every equation, we use at least one equal symbol. But now in most of the programming languages, you can see there is double use of, or 2 times use of equal symbol, and definitely single use of equal symbol and double use of equal symbol definitely have 2 different meaning. In programming languages, if we use a single equal symbol, that means assigning. We are assigning. Suppose we have a variable, and then we use an equal symbol, and then we use an expression. That means that expression is assigned to that variable. Here, so the single use of equal means that something is assigned to some other thing. If we write an a equal to b. For example, if you write a equal to b in programming language, that means b is assigned to a, and that's the only that's the meaning, the exact meaning of the use of single equal. But if we use two equals simultaneously, for example, a double equal to b, a equal to b, if somebody use it in a programming language, that means we have 2 expressions, a and b. 2 expressions, we have the expressions a and b. Here we are actually comparing the expression a with the expression b. What does it mean? The double use of equal symbol. Double use of equal symbol, if it is used between two expressions, A and B, suppose A and B are two expressions. If we use it between or to connect two expressions A and B, that means we are just comparing the expression A with the expression B, or vice versa. So we are comparing the expression B with the expression A. Then what will be its result? Every comparison can give us either an yes or no answer. So that, for example, if A here itself in this example, since we compare A with B, if A is equal to B, if it is found that A is equal to B, then the answer is yes or true. So we can say it in two ways, the yes answer or true answer. So both have the same meaning. But if the comparison says that if they are different, if suppose A is less than B, or suppose A is greater than B, then we don't have that equality. And then what answer we are going to get? The answer is no. So every assignment operator is going to give you two answers, either yes or no, or true or false, and this kind of answers you're going to get. So this is the thing that is going to happen in this case also, in the case of sagemath also. So when we use two double equal symbol, double equal symbol in an expression, it simply means that we have two expressions, the left hand side expression and then double equal to symbol, and the right hand side expression. We are combining the left hand side expression with the right hand side expression, and then the system will generate only two answers, either true or false. Okay. And that is explained here in these lines. And you can see if now an example of an assignment operator we can see here. See this command z equal to 3. Z equal to 3 means what does the meaning of this line? It means that we are creating a variable z. A variable z is created, and to that variable the number 3 is assigned, or we are giving the value to that created variable. And then if you type z and you take the, after that if you take the output, then you will get the value assigned to that variable as the output, and then 3 will be the output. Now if we then evaluate, okay, then try to suppose we try to evaluate an expression. You can evaluate an expression using sagemath after doing after doing this assignment. You see this, how does it happen? Let's see. See here, suppose we are using the expression 5 plus z cube, 5 plus z cube, and then but how can we write it? It should be written in a specified way. See here, first you you can type first 5 first, and then 5 first, and then you can type a plus, and then z you can type after that z cap 3. That means z raised to z power 3. It means then we get that way you can type this way only you can type it in sagemath. So z 5 plus z cube should be written in this way. And then if you take the output, for taking output, once again I shall remind you that for taking output you have to press alt and enter key together. You have to press alt and enter key together, and then you will get the output. That output will be 32. Why? The output is 32 because already you have assigned the value 3 to the variable z. So z contains the value 3, and you have written an expression 5 plus z cube, and then if you take the output, then automatically what happens, the value of z, or the value stored at the place of z will come to this place, will be entered at the place of z, and then the whole expression will be calculated. As a result, then 5 plus 3 the whole cube, 3 cube you know it's 27 plus 5 equal to 32, and that way we get that output. So this is an example of value or storing a value at a variable, and then using that value to calculate more complicated expressions. Then coming to that that point, assignment, equality or comparison expression, comparison operation, and that thing I have little bit I have explained that. Now see this expression, x double equal to 2. See, x double equal to 2, suppose we write it, assuming that if you assume that already if you have given the value 2 to x, if you have already assigned the value 2 to x, suppose you have assigned using the co-calc system or using the sagemath system, if you have already assigned the value 2 to x, and after that if you write x double equal to 2, then what will it do? It will compare whether the value, since already x is equal to 2, already the value 2 is assigned to x. Therefore, now coming to that the second expression part, coming to this part, already we have 2 stored at the place of x. Therefore, this 2 will be compared to 2. Compared to the new 2. New 2 means the right hand side number which is given the right hand side of this expression. The left hand side is already x, but it is equal to 2. Already it is equal to 2. So that 2 is compared to 2, and since both quantities are equal, since left hand side equal to right hand side, the system will generate the answer true or yes answer or true as the answer. But instead of that, or on the other hand, if you write the expression x double equal to 3, what happens? Since already x equal to 2, then 2 will be here as a result of this expression. 2 will be compared to 3, and you know that 2 cannot be equal to 3, so this expression can generate only the value or the output false. So that is the difference of the assignment operator. I mean the single use of equal and the comparison operator. So see, double use of equal can be called a comparison operator. Comparison operation or comparison operator. So comparison operation and single use of operation, that is assignment operation and comparison operation, and these are the two operations. These two operations are also very common, and the difference is now very clear. I think you have got an idea about that difference. Okay. Another common usage of expression. Now we are going to discuss more about the assignment operator. It is the same thing, same idea we are going to discuss, because two time equal symbol is going to be discussed. We are going to think about or going to discuss more about double usage of the equality symbol. See, consider this expression, the expression x square plus x plus 1 double equal to 0. See, and if that expression you know that it is x square plus x plus 1 equal to 0, it's an equation. If that equation, suppose we want to solve this equation, we are very familiar. We quite common. You know about this kind of expression used very commonly in your mathematical classes. But I know that you might have faced the situation of problems in which you are asked to solve the expressions like x square plus x plus 1 equal to 0. And when you solve this, you are going to get two values for x. You are going to get two values for x. When we solve the expression x square plus x plus 1 equal to 0, you know the reason also, because it's a polynomial equation containing only one variable, containing the variable x, and its degree is equal to 2. So naturally, you know that you have learned the theorem saying that it can generate exactly two solutions. Solution means the values of x, two values. It can generate two values for x. Sometimes maybe a real value, in some cases it may be a complex value. In some cases, there are situations in which the values are same. Likewise, there are different situations. But whatever may be the situation, whatever may be the type of the solution, there exists very clear and very easy way to solve this kind of expressions. This kind of polynomial equations can be solved in its variables. So what does the word solve means? Finding the value of the variable used in an expression, in an equation. Finding the value of the variable used in an equation is the meaning of the word solve in mathematics. So if you want to solve, what kind of method is there? In sagemath there is a command. In sagemath there is a command. That command is solve, SOLV. See, you can see that command, and we are going to see the syntax of that command also. See, you can simply write solve, SOLV, solve, and then in bracket you can in regular bracket, in ordinary bracket, you have to use a square bracket. And in this square bracket, so first you have to use ordinary bracket, and then in the square bracket you should write the expression fully, completely, without any error. You should write following the sagemath's rule. You have there exists syntax of a special syntax for sagemath. For example, for raised to power expression should be written like this: x power x cap 2. And that way, using the syntax, you have to write that expression. Then you have to put a comma, and then after that you can write the variable in which you whose value you want to find. So this is the syntax, and then after that, after writing that variable, you have to close it. So see the syntax once again: solve. Then in bracket, first you should write that expression in square bracket, and that is separated by the variable. Here the variable, independent variable, is x. After that, if you take the output using sagemath, you are going to get this output. You can see that the output will be like x equal to x double equal to minus 1 by 2 divided by 2 into I into square root of 7 minus 1 by 2, and second one again, x is equal to x double equal to plus 1 by 2 into I into square root of 7 minus 1 by 2. Now by a cross examination, by a cross checking of this expression, reveal that it's a complex expression. It's because, and you can see this part is it's in the form a plus or minus a plus or minus ib. It's in the form a plus or minus ib, a plus ib and a minus ib, or x plus or minus iy. It's in the form x plus or minus iy. Then what is x here? X is the real part. That the real part is but a slight difference is that here that real part is written as the second term here. In the output you can see the real part is written as the second term, but it is there. The second term is that real part is there. The real part is, so it can be taken as x. And then y, what is y? Y is this expression. Iy is this expression. In this expression, you can see that I. This is the symbol for I, the capital I. But instead of a small I, you can see capital I is used. Capital I, and into that capital I is multiplied by a number part, that is minus 1 by 2 into square root of 7. So here b part b is equal to, the number b is equal to minus 1 by 2 into square root of 7. And then you can see how by trying with many examples, simple and more complex examples, you can see how the command solve works. We are going to see it after this discussion. I will demonstrate that also. The command solve solve. See, now here it is given what is given here, a more general form of syntax of the command solve. You can see here, you can see a general syntax, a more general syntax of the command solve, and that is solve, then in bracket LHS means left hand side expression. See the expression, solve in bracket the expression and then comma variable, and that is the syntax. So you should make this syntax by heart. Using this syntax, in this syntax you can see that this is left hand side equal to double equal to right hand side, and then variable whose values you want want to find, actually you can write those variables as the second part. So see, another expression solve, another example is given here, solve in bracket x square minus 2 equal to 0, the comma x. See, the output will be x is equal to minus square root of 2, and the second value of x, and there is another value for x, that is x is equal to plus square root of 2. And it's very interesting that at the same time, using the same or similar expression, you can find values of more than one variable. See how useful, in how many useful ways this sagemath system can be used. You are going to see, it's very amazing, very interesting. You can simultaneously find the values of two variables which are present in one expression or two expressions. One or more expressions in two or more expressions. That means you can use two or more expressions together to find the values of x and y. See one example. First, x comma y equal to variable x or y, variable xy. So this is a step in which we tell the system that x and y are two variables. A system of m equations, here it is given that it's mentioned that a system of m equations and n unknowns can also be solved with the use of the same command. This very simple command can be used to solve more than one equation which contains more than one variable. See, actually m equations in n unknowns can be solved using this. A very simple example for that is given here. So for that, first we declare that x and y are two variables, and so that is done in this way. X so y equal to variable of x comma y, and then solve. There are two equations actually given. Two equations are given, that is 2xy minus y equal to 3 and x plus 4y equal to minus 2. And these are the two equations or expressions. So after first we write, then we write the first expression in square bracket, the first expression separated by commas, the second expression, and then separated by commas two variables x comma y. So remember the syntax, it's very important. You should not make any mistake while typing that symbols, and this is especially by putting when we put brackets and commas. And you can see when it is implemented, you are going to get the solution x is equal to 10 by 9 and y is equal to minus 7 by 9. Okay. Okay, we are going to now. I am stopping here the discussion. I am going to stop the discussion here now. I am going to I am going to the demonstration part next. Okay, the demonstration using CoCalc. We are going to demonstrate it using CoCalc. So starting the project. All those things so that we have discussed will now be demonstrated. No, yes, the project is now ready. No, it's not, still it is waiting. You have to wait for the project to start. What happened? Still it is slow. Project is very it's waiting to be renewed. Okay. Okay, if it is not working, taking this much time, then we will try to open one more co-calc project. Okay, let's open another co-calc. Some connectivity problem with that. Okay, I think better opening another one. Okay. Yeah, you can see automatically the things that we have done in the previous class, in the previous session. It is already there because it will automatically save it. The system will save all those things. Now you can we can try these commands. Now, what is our first command? Okay. That is algebraic expressions we are going to see. See this. Let's see how this works. And pi first, by typing pi, that's just simple typing pi. Okay, then control enter. Then you are going to get nothing. Yes, it's an error. What's the problem? Okay, instead of that, let's type pi x equal to pi pi x equal to pi, and then if we control enter, if we type, then also it's a problem. I trace back the most recent call. Let's see that. Let's try this. Okay, IPython import. Okay, IPython, I think something needs to be import IPython. Import. I need to import IPython, and then we'll try. Okay, we'll debug this error, and we'll come back soon. Okay.